Hi, today we are going to learn about the growth or decay model of exponential function. So, exponential function of growth or decay model follow this formula. Value n times t equals initial value, let's say that's a, and then b to the t power. So this is a, we call it initial value. And then this b, we call it growth factor. So initial value is the original value, and growth factor we're gonna learn soon. So let's read the question right here. Tony purchased a rare 1959 Gibson Les Paul guitar in 2000 for $12,000. Experts estimate that its value will increase by 14% per year. Write an exponential function and just set up the equation to find the price in 2008 and when the value of the guitar will be 60,000. So let's set up the exponential function first. To do that first, let's find a initial value and let's find the growth factor here. So initial value is all the time original value, which is initial value here 12,000. This is a 12,000. That's a. Initial value a is 12,000. And growth factor is b. But you need to find the growth factor here. So increasing or decreasing percent. So growth or decay model we call it. All the time 1 increasing r percent, then 1 plus r. Decrease r percent, 1 minus r. That becomes growth factor. So in this question, r, because this is increase, then we're going to use the growth model. So, and then here you might see as decrease, then you might use minus decay model right here. So 14% is 14, and percent all the time you use 2 decimal points, so 0.14. So 1 plus 0.14, which is 1.14. That means now this equation become, if you use that model, Vt equals initial value, which is 12,000. 12,000, that was A. B, growth factor is 1.14. 1.14, and then to the t power. That's a exponential function in this problem. Okay, now they're asking when the price in 2008. So from 2008, 8 years passed. So t years time is a. So V8, so 12 and 1,000, 1.14. This t is 8. So you can use calculator. This calculate 1.14 to the 8th power times and then 12,000. Then that will be answer. Or we can just leave it answer for down like that for now. And then 3. What's the time when guitar is 60,000? So V. So value now here, outcome, the final value right there. That's 60,000. So I'm going to use the 60,000 right there, and then 12,000 right here because I need to find the t like that. You can use a graphing calculator and then find out, or we can do it later. So for now, I'm going to leave it answer like that. Everybody got it? Okay, so now decay model, let's do it here. So initial value, okay, the value of the truck both new for 32,000, decrease 8.5% each year. Okay, and so initial value is 32,000, right? So this is 32,000, which is A. And growth factor in this case, because decrease, it says a decrease. So we follow decay model, which is 1 minus R. R is in this case 8.5. So 8.5%, use 1, 2 decimal place right here, then 0.085. So 1 minus 0.085, that become 0.915. That, if you calculate it, that's 1.195. That's growth factor. So equation here, same thing, Vt value in years Okay, so original initial value 32,000 and gross factor 0.915. This is smaller than 1, then you can say decay factor. Still you can call the growth factor, but smaller than 1, we can, among those you can say decay factor. This one you can call growth factor because bigger than 1, this is decay factor. Okay, and then now in 6 years, that means t is a 6 now. 6 here, 32,000 and 0.915. This is 6, and price will go down. And then when the value become 10,000, so value is here, final value here. So 10,000 equals 32,000 and 0.915. You need to find t, but that one you need to use a graphing calculator, or later we're going to learn it. So that's how you do it.